geometry students, and we're here in section 4-2, and we have some new vocabulary. We have auxiliary line, exterior angle, remote interior angles, and flow proof. Okay, so in this section we have theorem 4.1. Again, you don't need to actually know the number, but it's called the triangle angle sum theorem. Okay, and I believe this was proven on Mathia. But what it says is, in a triangle, right, that the sum of the three angles is equal to 180 degrees. So if we add up angle A with angle B and angle C, you will always get 180 degrees. So triangle angle sum theorem. Okay, and so there it goes. This is what they've proven. This just was shown on Mathia, maybe a little bit differently, but here it is again. Okay, if you want to take a picture of that, that'd be awesome. Okay, here we're going to use the triangle angle sum theorem. It says the diagram shows the path of the softball in a drill developed by 4 players. Find the measure of each numbered angle. Okay, well, we can find angle 1. The reason why we can find angle 1 is because the sum of the 3 angles, 43, 74, and the unknown one that we're looking for, has to be 180. And so if you add up the 43 and the 74, we can easily see that we already have 117. So think about it. You can probably do mental math there, and you can figure out angle 1. So you also know that angle 1 and angle 2 are vertical angles. So as soon as I figure out angle number 1, all right, we're going to know angle number 2 because vertical angles are congruent. And once I know angle 2, we can use that with the number 79, and so that we can figure out what 3 is by subtracting the sum of these two, right, from 180, and that would give me the angle 3. So let's see. Okay, let's solve. Angle 1 plus 43 plus 74 equals 180. There's my 117. We subtract and we get angle 1 equals 63. So we know angle 1 and angle 2 are going to be the same. So angle 2 also equals 63. 63 plus the 79 from that second triangle plus the measurement of angle 3 is 180. Add those together, subtract from 180, and we get an answer of measurement of angle 3 equals 38. All right, check your progress. Okay, I'm going to have you pause your video and see if you can figure out what the measure of angle 3 is. Okay, and the answer is 57 degrees. And you say, well, how did we get that? Well, we got 57 degrees by taking the 67 and the 38, and that gave me a value of 105. That tells me that the number 1, if we subtract 105 from 180, that the angle number 1 should be 75. If angle 1 is 75, so is angle 2 because of congruent angles. Vertical angles, are congruent. So therefore they have the same measure. And then we have 75 plus 48, and that gives me 13, and that gives me then a 12. And then the difference from 180 from the 123 minus from the 180 gives me the 57. All right. We have this angle theorem called the exterior angle theorem. So it says basically if you have a triangle, okay, and this was also looked at a little bit in Mathia. It might have just you might have missed a little bit. There wasn't a lot about it. So we have angle 1 right here. Okay, angle 1 is an exterior angle. It's not actually an angle of the triangle. Okay, but it's actually equal to the sum of the B and the A. Okay, and the reason why is because the exterior angle 1, right, and and angle ACB form a linear pair. So let's just say that, right? Measurement of angle 1 plus the measurement of angle ACB, or let's call it, I guess we call that angle C, is equal to 180. Okay? And since that's equal to 180, okay, then we know if you subtract angle 1 from 180, so we get measurement of angle C, we can see is equal to 180 minus the measurement of angle 1. Okay? So what this shows us is that the sum of these two angles must be the same, or must be equal to the angle 1, because they both equal 180. So you can show that as a proof. Let's see if they do that here. Yep, they show the proof here. Exterior angle theorem. And there's our flow proof. Given triangle ABC, we know measurement of angle A and B and measurement of angle 2 must equal 180. Okay, that's the triangle angle sum theorem. And then we also know angle 2 plus and angle 1 form a linear pair. Therefore, they're supplementary, and therefore they add up to 180. And then we can do some substitution. Since they're both equal to 180, we can set the 3 pieces here, okay, 3 pieces here, equal to the 2 pieces on this side, since they're both equal to 180. And then that's based on substitution. And then we can subtract the common things from both sides. As you can see, would be then subtract measurement of angle 2 from both sides. And then we have that the sum of the measurements of these two, A and B, actually equal the measurement of angle 1. Kind of neat. All right, use the exterior angle theorem. It says find the measure of angle FLW. Okay, but what we know is, and so basically, it's the value of whatever 2x minus 48 is. But in order to figure that out, we have to probably figure out the x. Well, by the theorem, we know that 2x minus 48, which is the exterior angle, is equal to the sum of the other two angles, one of which is unknown and one of which is 32. So we have x plus 32. So you can see then what we're going to do. We're going to subtract x from both sides and add 48 to both sides and solve for x. When we solve for x, you can easily see what that's going to be. X is going to be 80. So let's see what happens. Okay, exterior angle theorem. So there we go, x equals 80. Once we know x equals 80, remember we're trying to solve for the measure of angle FLW, which is 2x minus 48. So we're going to do a little substitution. 2 times 80 minus 48, just by putting in, right, the number 80 right in for this x right here. All right, check your progress. The piece of quilt fabric is in the shape of a right triangle, and we're going to find the measurement of angle ACD. Go ahead and pause your video and solve. Okay, if you got 40, you're correct. Now let's show you why. Okay, so in this problem, we know that 3x plus 10, which is my exterior angle, okay, that must equal the sum of the other two angles. So we have an angle x, and we do actually have an angle here of 90. So we're going to have 90 plus x as the sum of those two other angles. Okay? And so we're going to subtract x from both sides, subtract 10 from both sides, solve for x, and there we go. We found the measurement of the angle ACD. Oh, wait a minute, 2x equals 4. Ooh, x equals 40. Let's see if this works out. X equals 40. Okay, and if x equals 40, and we have 90 plus 40, which is 130, that would mean that the angle down here, okay, because that's going to be 90 plus 40 is 130, this angle down here should be 50. Okay, and if I put a 40 in here, I get 130 degrees, which is expected as well. But what were we trying to find? We're trying to find the measurement of angle ACD. So it looks like they have a mistake. Triangle, the angle ACD, okay, is not actually x. Okay, so it actually should be 50. So hopefully you got 50 instead of the 40. This is actually just the value of x. This is not the value of the angle ACD. All right. So with the triangle angle sum theorem, we have some corollaries. Okay, and it says that the acute angles of a right triangle are complementary. Okay, triangle angle sum corollary. So we have to have, again, acute triangles of a right, or acute angles, right? I'm sorry, acute angles of a right triangle are complementary. If angle C is a right angle, then A and B are complementary. What that basically means is, since we know that the sum must be 180 for all three of them, if you're dealing then with a 90 degree or a right triangle, then the sum of the A and the B must be 90. And that's actually what complementary means. The measurement of angle A plus the measurement of angle B is 90 degrees. Therefore, they are complementary. Okay, then it says here, 4.2, there can be at most one right or obtuse angle in a triangle. Okay, you wonder why. So if there had been more than an obtuse angle is more than 90 degrees. So if you have, let's suppose that you can have an angle or two angles more than 90. So you have two angles more than 90, okay? Even let's say 91, right? And let's say another one 91, just a little bit more than 90. Well, the sum of those two is already 182, and you won't have enough to find the third. Okay? Because remember, the sum has to be 180. And same thing with a 90 degree, right? You can only have one right angle, because if you had two right angles, you would already have 180, and there would not be enough for the third angle. Right. So now we're going to try to find the measure of each numbered angle. So we can probably start with angle number 1. Right? And so if you think about angle number 1, that is an exterior angle. Right? And that exterior angle is going to be equal to the sum of the two other angles in the triangle, 48 and 56. So we go ahead and do this right here, right? And we have 104. Okay? So angle number 1 is equal to 104. Well, since we know angle 1 is 104, then we can go right to angle 2, and angle 1 and angle 2 form a linear pair. Therefore, they're supplementary. So we're going to take 180 minus our 104, and that gives me my 76. All right, so we're getting somewhere. So angle number 2 is 76. Okay, let's jump to then, we can do these in any order we want to if you wanted to. So can you do angle 5? Okay, well, angle 5, since we know 90 plus 41 are my other two angles, that gives me a 1 and a 131. So the difference between 180 and 131 is 49. So it looks like we have an angle of 49 degrees for angle 5. Okay, so think about how we're going to get the angle number 4, okay, and the angle number 3. Okay, so think about that for a moment. Well, angle number 3, okay, you have the angle sum postulate that we can take the 90 degrees that's right here, okay, and the 48 that's already there, and then we have the unknown angle number 3. Well, and the sum of those three have to equal 180 because they form the linear pair altogether. So we have 90 plus 48, right, plus measurement of angle 3, and that must equal 180 degrees because they form that straight angle. So we have 100 and what, 138? So we have 138 plus measurement angle 3 equals 180. Well, I think we can all see that then the measurement of angle 3 would be 42. Okay, so we have angle 3 now to be 42. So that works out as well. So we have angle 3 is 42. Oh, look at that. We have angle 4 is the only one that's missing. And if you look right down the middle, we have this nice big triangle right here. And it's a right triangle because of this measurement right there. So we have 90 plus 42, right, as my sum of my two, and that's going to be 132. And then the 4 would be then the difference from 180, and that's going to give me an answer. It looks like a 48. Okay. So we have 56, we have 104. Okay, so we got that one right. Okay, measurement 1 and 2, they form a linear pair. Okay, therefore we have the 76. We got that one right, looks like. Let's keep moving on. They do angle 3. They go 90 minus 48. Okay. If two angles form a right angle, then they're complementary. So they did 90 minus 48. Got 42. I think that's what we got when we did it. Yes, we did. Okay. They just did a slightly different way. And then triangle sum theorem. Angle 4 ends up being 48. And then finally angle 5 that we did a little bit earlier, we got an answer of 49. Okay, so there's our final answer. Now I'm going to go back to angle 5. I don't remember if I got the 49 or not. I can't remember. Yep, that's what we got up there. At angle 5 equals 49. So that's good. Got them all right. You hope your teacher will get them right. All right. Sorry, I have to page through that. All right, so check your progress. Okay, take your time on this one. You're going to try to find the measurement of angle 3. Okay, pause your video. Try to find measurement of angle 3. Okay, they have angle 3 is 85 degrees. Okay, let's go through this. We have angle 1 can be found by adding up 85 and 45, which is 130 degrees. Then we know angle 1 has to be 50 degrees because the sum of angles in a triangle must be 180. And 2 and 1 are vertical angles, therefore they're congruent, therefore they have the same measure, so 2 is 50. Awesome. Okay. Now it looks like we have 135 degrees. This is kind of tricky. Let's see what happens, how we're going to do this. So 135 degrees is an exterior angle of this triangle right here. So it tells me that the sum of these two, okay, I guess would have to be 135. So we already have 75 of it. So this angle here has to be 60. We probably don't need that because we could have just said, right, 135 and 4 make a linear pair. Therefore, this 4 then has to be 45, right? So this 4 is 45, and this angle here, which is vertical from it, must also be 45. Okay? So what we have so far is in this triangle that includes the 3 that we want is 50 and 45. 50 and 45 add up to what? 95. And then is 95 plus 85, 180. And it sure is, isn't it? So 85 is the right answer.